example number 2, the AEC test, or whatever you want to call it. I don't know what it's called exactly. Anyways, here we go. We want to find the resultant of these three forces. You have F of A, force of B, and the force of C. And you're going to use this most often when you're doing trusses. For instance, you'll have a truss, force going that way, a member that's pulling that way, a member that's pulling that way, or pushing and whatnot, and a member that's pulling this way. And you'll have, let's say, another member right here that you have to find. You have to figure if it's in compression or tension, and then you have to find the magnitude of that certain force. That's the practical application of this. So it is important. Once again, the guy in the book, he goes ahead and he looks like he scales them and adds the tails together, which would be fine, but it's just not practical. You're not going to do it. So you take this one and you put it over here, and you come to about there, parallelogram, of course, and then you take the parallelogram of that, which would be about right here. So give or take, you add that one to this, you're going to get about right here. But who knows what it is, and if you try to scale, it's going to be ugly and you might get it wrong. So the best way to do it is to once again take components of these forces. So that's what we will do. We'll start off with FA. And once again, you want a component in the FA of X direction, and you want F of A, the force of A, in the Y direction. We'll go ahead and take it down here. There it is. You have 45 degrees is this angle. So you have coming this way. Now we know this is negative because our sign convention is always going to be, this is the positive X direction. This is your positive Y direction. Always. Well, not always. You can change it up, but for our purposes, we're always going to do that. And 99% of the time you will. So there's it. This is going to be, we already know this. This is F of A, which is going to be your hypotenuse. This is going to be F A Y, F A X. Alright, there we go. And SOHCAHTOA is going to be 1,000 times important. If you don't know, look at the Khan Academy, they'll help you out. SOHCAHTOA, which means sine of your angle equals opposite over hypotenuse. And the cosine of your angle equals adjacent over hypotenuse, and your tangent of your theta of your angle equals your opposite over adjacent. That's what OA, and O is always opposite, H is always hypotenuse, A is always adjacent. Alright, so we go up here, we use this. We know the angle. Here's our angle right here. So the opposite's going to be FAY. When you're doing opposite, you want to do sine. When you do adjacent, which is FAX, you're going to want to use cosine. So let's go ahead and put it out here. And I'll show you the algebra on here. So right now we're going to figure out this, which is FAY equals what? And it is going to be, here's your angle, so it's opposite. So you want to do sine. Sine of theta. You want to do sine of the opposite because you know hypotenuse. You know the angle. The only thing, you have one unknown, you're going to solve for that. You have your over there. So when you look at it, you have sine of your angle, which is 45, equals, opposite is your FAY, over hypotenuse, which we know the hypotenuse FA equals 1,500. So there you go, 1,500 pounds. If you remember your algebra, which you hopefully should, you can simplify. You want to solve for FAY, you have to move this over there. How do you do that? You multiply this by this side by 1,500 and this by 1,500. That ends up canceling out with this 1,500 pounds. And you're going to multiply over here, 1,500 pounds. This 1,500 pounds divided by this 1,500 pounds is 0. And that leaves you with FAY. That FAY equals 1,500 pounds, sine 45. So let's go write that down here. FAY. Tell you what, we don't need to write it down here. We're going to write it up here. There that goes. 1,500, and that's it. Pounds sine 45 equals FAY. Oh, son of a gun. Let's just erase it, not to confuse anybody. 1500 sine 45 equals FAY. Let's put that down there. Then we said the opposite, the adjacent is right here, which is your FAX. So essentially you're going to have, we want to do, since it's adjacent, we want to do cosine. Cosine of your angle equals adjacent over hypotenuse. Once you come down, your angle is 45. Your adjacent is FAX, force of X in the force of A in the X direction, that is, once again. And you do the same thing. This ends up going to this side, 1500. And you go up here, and you will have 1,500 pounds cosine 45. And when you get further and further on, you'll be able to do this in 2 seconds. It's always going to be hypotenuse times, for the adjacent angle, you're always going to do the hypotenuse times that angle. Gets your adjacent hypotenuse times the opposite. Remember, times the angle gets you the opposite sine. That makes sense. I kind of jumbled that up, but I think you understand it. If you don't, once again, go to Khan Academy. It'll help you out. And knowing what you know about 45-degree triangles, these will be the same, and they should be, and we'll prove that in a second. So 1500 cosine 45 equals 1,000. Let's make that bigger. 1006.7, let's call it. And this is 1500 sine 45 equals, like we anticipated, 0.7 pounds. Alright, so once again, just to think about this, if you add this force of A in the X direction plus the force of A in the Y direction, if you go like that, plus that, you will get force of A. And that's what we got. But once again, I didn't really look at my cosine convention, and you have to be good at this, because if we look at it, our X direction is going to be negative, and we need to put it up here. Your Y direction is going to be positive, so we're okay. Moving right along, we're going to get a little bit faster. B of X, and then B of Y, or B in the Y direction, not to be confused with anything else. This is actually extremely easy. If you just take a look at this, well, it has no Y component. Y is 0. So there you go, 0 pounds. Great. Well, it's all X, and it's positive X, so we're just going to do this. And you're done. Okay, moving on. If you have questions about that, just let me know and I can explain it further, but it should be pretty obvious that this has no, given your sign, your convention here, you're saying that X is straight over and Y straight up. So there is no Y component to that one. Alright, now going to X. Let's come down here and let's do the same thing. And it looks like both of these are going to be negative. So there's your FC. I'm not to scale, obviously. Let's say this is 60 degrees. And there's going to be your X component. And there's going to be your Y component. And they're both going to be negative. So this is FCX, FCY, and this is FC. Alright, that's your angle. Opposite is FCY. Okay. Let's go ahead and say what this equals, 2,000 pounds. So knowing what I know and knowing what we did earlier, and you can work it out if you want to, the algebra, but I'm just going to go ahead and say 2,000 pounds times, and I want the opposite. So here's your angle. You get opposite and you get Y. So FCY is your opposite, so we want to do sine, because SOHCAHTOA, sine is opposite. Sine of your angle is 60. And that there. And the other one is always going to be opposite of that. So if this has to be sine, because it's opposite, this should be adjacent, so it's cosine. The adjacent member is right here. FCX, yeah, that's what we wanted. So we're going to do 2,000 cosine 60, and it's 1,000 pounds. Now, before I forget, I'm going to look at the convention here. Oh, it's negative, because we're going, and then negative x direction. We've already said this is always going to be positive x going to your right, and y is always going to be positive going up. So that's negative. Y is also going to be negative. So 2,000 sine 60 is negative, remember, because we're going down, 1,732.1. Let's say it's actually 0.0508, blah 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 blah, but we just rounded up to 0.1. That's more than enough. Nobody's ever going to really, in reality, you're not even going to care about 0.1 pounds. That's not going to do anything. Alright, so there we are. We need to now add the components together. You need to add all your x's and all your y's, and you will get your resultant like we did last time. So we go to your eraser and create some space. Actually, I don't need to do that. I'll just go scroll down. Yeah, but I want to see those. We'll just erase. Erase our convention there. Okay. Now we take all the FAX, FABX, FCX, and we want to add those together. All that, we should come up with your resultant, which I always call FR, and the x direction equals what? And then we're going to say FAY, FBY, and FCY. Equals, of course, FR in the y direction. Going up here, we look, FA equals negative, you got to remember to do that. FBX equals 2,500, and that's positive. FCX equals negative 1,000 pounds. Okay, negative 1060.7 plus 2,500 minus 1,000 equals a positive 439.3 pounds. Go over here. FBY equals 0, easy enough. FCY equals negative 1,732. We do the math, add them all together, and we get a negative 671.4 pounds. Alright, now you look at those and you're like, okay, I have the resultants. They result in the x direction, result in the y direction. So let's chart it out. Here's your beginning point. And you want to go x, you want to go positive 439. Let's say that's good. Then you want to go, let's say it's 9.3 pounds. And you want to go down 671.4 pounds. You don't really have to put a negative because it's going down, and you'll know that. And here is your resultant, or the parallelogram theory, of course. But it's easier. The parallelogram theory becomes a lot easier because you're always dealing with rectangles or squares, of course, if you have 45-degree angles. And you have to find your hypotenuse, which is your resultant. This is FRX, FRY. And the easiest way to do that is the Pythagorean theorem. FR equals a square root of FRX squared plus FRY squared. And let's look at that. 439.3 squared plus, run out of time so I can't do pounds, 671.4 pounds. And the answer is, for a force resultant, and remember it's coming down, it's still got that different orientation there. You gotta remember. But your answer is 802.03 pounds. And you check it, and it is exactly what he has. So 803 pounds in this direction.